Cold War process of defense procurement is in need of a major refresh. While it still produces world-leading military systems, its escalating timelines and costs are unsustainable byproducts. The stark contrast with commercial industry warns the US military may have peaked, unless we find a better way soon. Right on cue, then, here comes digital engineering, a new commercial technology that's lending a legitimate art form to military weapons buying with revolutionary, even stylish results. Yes, we just used art form and weapons buying in the same sentence. The Air Force and Space Force recently created an E-Series designation for digitally designed aircraft, satellites, and munitions. The US military currently uses a variety of uppercase letters designating aircraft. F stands for fighter, A stands for attack, B stands for bomber, T stands for trainer, and so on. But computerization is only part of the E-Series equation. The real art is observed in the real world. Just as architects capture physical structures, our digital engineers are capturing physical processes, virtually learning, perfecting, even automating them so that costly trial and error can happen cheaply on computers. Having a virtual rewind button seriously fast-forwards real-world program success. Take our first E-plane, the digitally designed AT-7A trainer jet, which we designed and built in just 36 months, a feat not accomplished since the 1950s with third-generation fighters. The new AT-7A Red Hawk is designed to prepare pilots to fly advanced F-22 Raptors and F-35 Joint Strike Fighters. The same digital approach also birthed our newly designated second E-plane, our most advanced sixth-generation flight demonstrator, years ahead of expectation. Last September, I revealed that the Air Force had already secretly designed, built, and flown a full-scale flight demonstrator of the 6th General Fighter Jet. Our 6th generation program, the Next Generation Air Dominance (GAD) program, entails what you might expect: cutting-edge warfighting technologies, collaborative teaming with autonomous Skyborg drones, and a lot of necessary secrecy. What you might expect is that it's equally about how we build future systems. Cold War procurement is dead on arrival against today's threats and technology speeds. Digital engineering is blowing the lid on what's possible, and not just for building better airplanes, but building airplanes better. Science fiction movies, like The Matrix, help us explain the underlying digital engineering technology we call authoritative virtualization. But art history also lends an interesting perspective about the innovative intersection of architecture and engineering. Not surprisingly, history is replete with architectural giants who harness science and technology to improve engineering execution. Filippo Brunelleschi, considered the founding father of Renaissance architecture, used mirrors and geometry to generate 3D drawings with perfect linear perspective. Leonardo da Vinci meticulously studied physics to create modern technical drawings of complex systems. Frank Gehry, dubbed by Vanity Fair as the most important architect of our time, employed computer-aided fabrication to achieve his physics-defying, Dali-esque buildings. Digital engineering takes computer creation technology to the next level, rendering not just the design of complex systems, but their assembly, environment, and even physical performance in high-powered virtual reality (VR). Prominent modern architect Mies van der Rohe once observed that whenever technology reaches its real fulfillment, it transcends into architecture. Digital engineering is transcending into a type of four-dimensional architecture, one that designs 3D systems and time-driven processes governing them in realistic VR, long before their physical twins are built. Architecture and engineering have endured a hit-or-miss relationship when plans transition to implementation. In constructing the world's largest masonry dome in 1420, Brunelleschi devised new engineering marvels to complete his 150-foot Florentine masterpiece, nesting two domes to avoid buttresses, laying bricks in novel self-reinforcing patterns, even inventing cranes and pulleys so ingenious they were later studied by Da Vinci. Other projects saw disastrous misses. The bursting St. Francis Dam, collapsing Tacoma Narrows Bridge, and falling windows of John Hancock Tower are cautionary examples of architectural design overlooking engineering reality. Even with use of computer models, Gary's MIT Stardust Center did not account for drainage, mold growth, or snowfall, ending in multiple lawsuits. No wonder Brunelleschi said that in building, only practical experience will teach that which is to be followed. Even with computers, true reality is hard to capture. Industries like the automotive field were the first to replace Brunelleschi's practical experience with digital ones. Computer-aided design tools had been widely used since the 1960s, but never replaced the rubber meeting the road of physical prototypes and testing. Since then, the trillion-fold boost in computer processing has morphed those early blueprint tools into today's powerful digital engineering models called digital threads and digital twins that replace real-world prototyping and testing with authoritative virtual sources of truth. A good case in point is Formula One racing, where there are no physical prototypes today. Every car feature and all physics governing it, even the rubber literally meeting the road, is painstakingly virtualized and anchored by authoritative test data. The end result is hundreds of digital cars being explored each season, even optimizing for individual racetracks, all without bending a single piece of metal. Real-world checkered flags attest just how authoritative these e-cars can be. The same breakthrough is now occurring for military systems. Our At-7A successfully virtualized production, constructing hundreds of E-planes digitally to optimize their physical assembly. Our new IGN used virtualized design to explore 6 billion digital missile variants in mere months. And our advanced 6th-generation E-plane is adopting Formula 1 style practices to out-iterate pursuing adversaries using our so-called Digital Century Series approach. To learn more about the Digital Century Series, and digital engineering in general,